called image-to-image translation. And really, all that means is it's an AI that's learned how to turn one picture into another. So, for example, it could take a totally standard MRI scan and, poof, generate a version that looks like you had a contrast agent injected, but without any needles at all.
And you can see right away why this is such a huge deal. For patients, it could mean no more nasty radiation from a CT scan or skipping an invasive injection. For hospitals, we're talking massive savings in time and money. For doctors, it could mean instantly filling in a missing scan from a patient's history. And for the entire field, it means creating these giant, diverse datasets to train even smarter AIs. The upside is just incredible.
But, and it's a big but, all of that incredible potential means nothing if we can't be 100% certain that these AI-generated images are medically sound. This is the trust problem. How do we get from impressive-looking pixels to something that's actually safe for patients?
The whole issue is captured perfectly right here. The paper points out that, yeah, we need human experts, radiologists, to check these images. But that process is incredibly slow. It's super expensive and, honestly, it's subjective. One doctor might say an image is fine, another might disagree. You just can't build the future of AI in medicine on a system that can't scale.
And this just lays it all out, doesn't it? On one hand, you have human validation, which is slow and expensive. On the other, the goal, automatic measurements or metrics that can check thousands of images in the blink of an eye, cheaply and objectively. This is what we need to make progress.
So, how is the field judging these AI images right now? Well, it turns out that most of the time, they're relying on just two main methods. So, let's meet the usual suspects.
According to reviews of the research, two metrics completely dominate the field, SSIM and PSNR. Get this, each one is used in about 75% of all the studies out there. They are the undisputed kings, which of course leads to a very important question. Are they any good at their job?
Let's break them down with a little analogy. Think of PSNR as a pixel accountant. It's super meticulous, going pixel by pixel, just calculating the raw mathematical difference between the original and the AI copy. Then you have SSIM, who's more like a structural engineer. It takes a step back and looks at the bigger picture, things like brightness, contrast, and structure, to see how the images feel.
Okay, so you've got an accountant and an engineer. Sounds like a pretty solid team, doesn't it? Well, what if I told you these two trusted judges have some pretty massive blind spots? Okay, let's look at this example from the research paper. On the left, we have the original perfectly sharp image, and on the right, we have the AI's attempt, which to you and me is just obviously totally blurry. So, I've got to ask, if you had to pick one for medical diagnosis, which one would it be? The choice seems pretty simple, doesn't it? And yet, our structural engineer, SSIM, gives that blurry mess a score of 0.92 out of 1. That's an A+. It thinks it's a near-perfect match. This isn't just a small mistake, it's a total failure. It shows that one of the most popular metrics in the entire field has a critical weakness. It can't really see blur. And the problems don't stop there. The pixel accountant, PSNR, is super inconsistent. Just changing how you format the data can make its scores swing wildly, so you can't even compare results from one study to the next. And they both completely fall apart if the image is just shifted over by a few pixels. A perfect image gets a horrible score just for being slightly misaligned. These are fundamental, deal-breaking flaws. Okay, so if our two star judges are unreliable, what's the answer? Well, the paper argues that we don't need to find one perfect metric. What we need is to build a whole team of specialists, a better toolkit. The core idea here is simple, but it's also brilliant. Instead of relying on one or two generalists who try to do everything, you assemble a diverse team of specialist judges, and you assign each one to look for a very specific type of problem. So let's meet this new evaluation dream team. First up is the perception judge. This metric, called LPI-FPS, is actually an AI that's been trained to see images like a human does, so it's great at catching things like blurriness. Next is the relationship analyst, which checks if the patterns of light and dark make medical sense. And maybe most important is the task specialist. This one asks the ultimate question. Okay, looks nice, but can a doctor actually use this image to do their job, like say outlining a tooth?
See, when you combine all these different viewpoints, you get a much more reliable way to validate these images. And this is not just some academic thought experiment. This is absolutely essential if we're ever going to bring this tech into real hospitals safely.
And the paper's conclusion really says it all. It's this careful, thoughtful combination of different metrics that's going to let us build and choose better, safer AI models. It's all about being way smarter about how we define success.
So the path to building that trust really looks like this. First, you have to know exactly what the image is for. Second, you assemble your team of specialist metrics custom built for that job. Third, you stress test the heck out of the AI. And finally, you use this powerful automated system to weed out any problems before an image ever gets to that final, expensive review by a human doctor.